So this is part 2 of piecewise functions. And so what we're going to look at are the greatest integer functions and the least integer function. So first off, let's think about absolute value again. Absolute value of x. If x is negative, we want to make x positive, so we multiply by a negative. Now, if x is already positive, we're not going to change anything. We're just going to leave x alone. And then, of course, if x is 0, nothing changes. So what we have here is this idea of making everything positive. And that's what absolute value does. What we're going to look at with these next two functions is we want all of our numbers to be integers. And instead of, say, decimals with numbers behind the decimal point. So first off, the greatest integer function. Now, the way we illustrate this, the notation, it looks like that. So what does this do? Well, again, we want to make all numbers into integers. Well, first off, if x is already an integer, nothing changes. It stays the same. So, for example, the greatest integer function applied to 5 is, well, still 5. Applied to 0, still 0. Apply to -3. Still going to be -3. Now, when we have something that's not an integer, we're going to have some number with digits to the right of the decimal point. Well, non-zero digits. This is what the greatest integer function does. It gives the greatest integer that's less than or equal to x. It gives the greatest integer that's less than or equal to x. So let's say our integer is 2.4. So we have 2.4. Now let's take a look at all the integers that are less than or equal to x. Well, this is not an integer, so there's no integer equal to this. But as we head down the number line, we have all these integers, and they go on and on forever. So if we think about all the integers less than 2.4, what we want of these is the greatest one. So that means it's going to be equal to 2. Now let's take a look at another one. So again, let's look at the integers smaller than negative 0.3. So we have -1, -2, -3, and they just keep on going. But of these integers, -1 is the greatest. So that means that's going to be our answer. One more. What about 0.3? Well, again, list the integers smaller than 0.3. Well, 0, -1, -2, -3, and so on. So of these, 0 is the largest. So the answer is 0. Now, one of the things you might be asked to do is to graph this function. So one way to think about this is, when graphing it, what are the values of x doing between the integers? So what we can do, take a look at our number line. So if we think about all the numbers between 0 and 1, the greatest integer that's less than these numbers, because all these numbers have integers that follow them, 0, -1, and 2, 0 is the largest. So they're all going to go to 0. And then all the integers between 1 and 2, I'm sorry, not integers, numbers. Well, these numbers, 1.1, 1.5, 1.70, 11624, and so on. Well, the integers behind this set of numbers is 1, 0, -1, and 2. The largest of these integers is 1. So they're all going to have a value of 1. And then same with these. They're going to have a value of -1. These have a value of -2. So let's graph this. So first off, if we apply the greatest integer number to -2, it's equal to -2. The greatest integer number, greatest integer function applied to an integer is just that integer. So for -2, it's going to put us right here. So if we have x, there's our function. So if x is -2, f of x will be -2. And then we also see that all these numbers here between -1 and 2, if we put those into our function, they're just going to map to -2. So all of these will have a value of -2. And then once we get to -1, well, once again, integers just pass through. So that means we're going to jump to here. And to recognize this jump, we'll put an open circle. And then all the numbers between -1 and 0, we put those into our function, they're going to go to -1. And then we get empty 0. So it jumps up to 0, and so we're in a little hole here. Now, all the numbers from 0 to 1, the greatest integer function turns those into 0. So the function will map to here until we get to 1. And at 1, we're going to jump up. And again, all the numbers between 1 and 2, the greatest integer function turns them into a 1. So all these x values, they're going to have a greatest integer function value of 1. And then we'll get another jump. Then it continues. So this would be our graph of the greatest integer function. And then it continues on this way, and it continues on that way. So anyway, now how might this look as a piecewise function? What it basically says is this. So let's work with x values, only some intervals. We're not going to do the whole x number line. But let's say x is from -2 to just short of -1. Well, according to the greatest integer function, the function will put out for -2. And then if x is between, well, from -1 to just short of 0, well, this all maps to -1. So again, -2 and the numbers between -2 and -1, they all become -2. -1 and the numbers between -1 and 0 become -1. Zero, and the numbers between 0 and 1, they all become 0. One, and the numbers between 1 and 2, they're going to become 1. And then 2, and the numbers between 2 and 3, they're going to become 2. And then this will continue on forever. So as a piecewise function, this is what this is going to look like. Now, there's another name for this. It's called a floor. And where you'll see this, if you ever program in Java, I think in Java it might be referred to as math.floor. It's used sometimes to come up with random numbers. So if you're in computer programming, if you're writing something and you want to generate numbers 1 to 10. Now I think these days there are functions that do this for you. But what used to happen is you generate a random number where x, some random number x, it could equal 0, it won't equal 1, but it's going to be something like 0 or something between 0 and 1. You then take this x, multiply it to 10, and then you would round it into an integer, and you would always round down to the nearest integer that's well, less than 10 times whatever x was. So if you had, for example, 8.5, this would round 8.5 to 8. If you had 9.999, it would round it to 9. If you had 0.1472, it would round it to 0. And usually to get a zero number from 1 to 10, you would have to then add 1. So something you might see would be, I don't know if I remember the exact function calls, but you might see math.random. That's times 10. And then you could take, ooh, I'm running out of space. I'm trying this again. So something like this could generate a random number from 1 to 10, something they used to do in Java. But I think, again, there's functions that let you do this where you don't have to go through all this. So anyway, that's your greatest integer function. So now let's take a look at the least integer function. So what the least integer function does, it's the least integer greater than x. So it's the least integer greater than x. So first off, what does it look like? It's represented like this. And again, we're just trying to turn everything into integers. Now, if it's already an integer, nothing changes. It'll pass on through. So, for example, put in 5, you'll get 5. Put in 0, you'll get 0. Put in -3, you'll get -3. So numbers that aren't integers, what happens here? Well, what it does is you consider all the integers that are larger than x. And of those integers that are larger than x, you pick the smallest one, or the one closest to x. So for example, let's bring back 2.4. So now we're going to look at the integers larger than 2.4. So 3, 4, 5, 6, and so on. So of these, three is least. So what this means last time when we had the greatest integer function of all the integers on this side of 2.4, we picked the largest one, which was 2. For the least integer function, we picked the integers on this side of 2.4, and we picked the smallest one. So the smallest of those integers is the number 3. So let's take a look at another one. So least integer function applied to negative 0.3. Again, let's look at the integers to the right of negative 0.3 on the number line. So of these integers on its right, 0 is least. And so that means that's going to be equal to 0. Now if we take a look at 0.3, again, list all the integers on its right. And 1 is least. So that means least integer function applied to 0.3 is 1. Now the greatest integer function, we looked at the integers to the left, and of the integers on the left, the greatest one was 0, or the one closest to 0.3 on the left side. But with the least integer function, we're looking at the integers on this side. We want the smallest one, or the one closest to 0.3, and that's going to be the number 1. So this has a graph also. So if we take a look at numbers between -2 and -1, the integers to the right are -1, 0, 1, and 2. So that means all these numbers will map to -1. Likewise, if we look at the numbers here, the least integer function, look at the integers to the right, the least one is 0, so all those will map to 0. Same thing here. They'll map to the integer on the right, the smallest integer on the right. So all of these will go to 1. And then all these numbers, they're going to map to this integer on the right, the smallest integer on the right, when we consider all the possible integers. So that'll go to 2. So now we'll graph this thing. So take a look at this. So all the numbers from -2 to -1, they're going to map to a value of -1. And then -1 will map to itself. So we'll have this. And then all the numbers between -2 and -1, they're going to have the same value, -1. And of course, again, -1 just passes through the least integer function. But then, when we take a look at the numbers between -1 and 0, now 0 going to map to itself. And then all the numbers between -1 and 0, and here, let me just make this note, they're going to have a y value of 0. So they're going to do this. Well, if we have a -1 here, then this must be a whole. So if there's a y value of -1, we're going to have a whole right here. We don't quite get to -1, x equals -1. So now let's take a look at number 1. Well, 1, again, it passes through the least integer function, has a y value of 1. And then all the numbers, for all the x values between 0 and 1, they also have a y value of 1. And then we're going to have a gap here. If there's a point here, there's going to be a hole, and then that's going to give us our jump. And then finally, for 2, again, 2 is going to pass through this value, or this function. And then all the x values between 1 and 2, they're going to have a y value, or function value of 2. And again, we've got this jump here. We've got a hole. So the only thing else I'll mention about this is that this is often called the ceiling function. And the ceiling function is another thing you'll see in computer programming. So if you have any questions, let me know, but that's pretty much, oh, let me show you how this breaks down in terms of piecewise function though. Don't want to forget that. So if we have numbers, say, -2, so if they're from -2 to -1, not equal to -2, but equal to -1, you have a value of -1. And then if you go from not equal to -1, but to 0, so this will give you 0. And if you have not equal to 0, but 1, you're going to get 1. And if you have not equal to 1, but up to 2, you're going to get 2. And that's it. So again, if any questions, let me know, and have a wonderful day.